Consider, if you will, a world without friction. A world where objects glide smoothly against each other, without resistance. A world where simple actions, like dancing, would be impossible. A world without friction would be dangerous.
All right, sorry about that. I accidentally hit stop screen share in the middle of the show. So friction. Friction is what we've been talking about, the invisible force of friction. So today, we actually are still talking about friction, even though we have magnets. Now, does everybody have their magnets to play with today? Give me a thumbs up if you brought your magnets. Perfect. Some of you do, some of you don't. Okay, and they don't have to. Landon, hold up your magnets really quick. What I suggested, hold it up to the camera really close. What I suggested was donut magnets that look like Landon has. But if you don't have that type of a magnet, that's okay. Even square magnets or any kind of a magnet will work. So let's watch a little video and then I'll give you a second to see if maybe you can go find some magnets around your house.
Hi, it's Doug. All right, check this out. Look at this.
Okay, wait.
See what I'm doing with this paperclip?
I am not. Yeah, I have some for you, Rye. Just a second. Okay, after this little clip, I'll come back to you guys and you can ask questions if you have them.
Hi, it's Doug. All right, check this out. Look at this. See what I'm doing with...
No, now it's not working.
Hi, it's Doug. All right.
Let me reload it and see if that makes it work.
Hi, it's Doug. All right, check this out. Look at this. See what I'm doing with this paperclip? I'm making it levitate. Ooh, how am I doing this? A magnet is making it possible. Today's mystery, we're asking, what can a magnet do? I'll keep this video short because the most important thing is for you to actually go handle magnets yourself. See for yourself what they can do. We're gonna start with the activity today. For this activity, your teacher has some magnets. Now, magnets come in all sorts of shapes, not just the classic horseshoe shape like you see on the left here. That's the kind you find in science kits. We're hoping your teacher was able to get some of these, the donut-shaped magnets, for the experiments you'll do today. So your first job today is we actually want you to just have fun playing with magnets. There's no special rules here. You're going to get 2 magnets from your teacher, and as you play with them, think about them. See if there's anything new you can learn or observe. Do some experiments. Like, you already know that a magnet sticks to certain things. It can pull on certain things, right? But will a magnet pull on anything? What kinds of materials does it pull on? Just metal? Any kind of metal? Can a magnet's pull go right through something like an eraser? Can you figure out how to use a magnet to make something float or levitate like you saw me do? So figure out experiments that'll help you answer these questions. So try your experiments, and then there's space here on the sheet where you could write down what you did and what happened. If you start experimenting and you realize you need some inspiration, your teacher has a handout with some ideas on it. Just ask for a copy. All right, so let's get started. Here are the supplies you're gonna need to start experimenting. You need at least 2 magnets. You need the worksheet to write things down on. You need a pencil. You need some paper clips. You need a piece of thread or string or light ribbon will work. A few 3x5 index cards. And your teacher will also have some things laying around made of different materials that you can test to see if they're magnetic. And don't forget, if there's anything in your desk or pockets, you can test that too. Have fun. When you're all done, come back and watch the next video. I'll show you some interesting things about magnets which you might not be able to do in your classroom.
Okay, so really what you're gonna need is gonna be a magnet to play with and at least some metal or some different objects that you can try to use your magnet with, and the worksheet. Give me a thumbs up if you remembered, because remember, it's your guys' responsibility to print out your worksheet ahead of time for class. Okay, I will go and I will get the link for you to print it out. But next week, remember, being part of being prepared for class is to print out your worksheets before you come, okay? So if you have magnets, go ahead and start playing with them. If you need the worksheet, I'll go get that right now. And if you don't have magnets, go start looking around your house for some, because you're gonna need them today. Bennett, go ahead.
I'm new here.
Yes, you are. And let me show you. I'll screen share while I go get the worksheet so that you can see how to do it too. So when we go to our website and you go into Pre-Scholar, and Riley, I printed yours out. Look on the printer and see if they're over there. And we go to Science. There's something called the class drive right here. So you click on the class drive.
Magnets?
On the stairs is a bag full of magnets for you. All right, in the class drive, you have a schedule and dive deeper. Dive deeper is activities that you can do after class and have fun. And the schedule is important because when you click on it, you look at the week that we're on. So today is September 30th right here. And you see that you should be at chapter 4. We haven't had a discussion on it yet, guys, but you should be at chapter 4 of Mesopotamians, the book. And we're talking about magnets. And right over here, do you see that? Experimenter's worksheet and magnets are weird. Vivian, do you have a question?
I do. I did not realize there was a book.
Okay, we'll talk about the book at the end of class. So I am going to pop in the chat box a quick link straight to this paper that you can print out. If anyone didn't print it out, you can go ahead and do so now. And the paper is basically asking you what kinds of things does a magnet pull on? And will a magnet go through paper or cardboard or other materials? And can you make a paper clip float? Can you make a magnet float? So I'll stop screen sharing and I'm gonna give you guys, about 10 or 15 minutes to just experiment and play. And then I want you to be able to come back and show us what you figured out, what worked. Go ahead, Miley. Do you have a question?
Well, just a minute. Will these magnets work? They're different shapes, though.
You tell me. Start playing with them. Yeah, right now you're just playing with magnets and seeing what you can do. Yeah, go ahead, Bennett.
I remember hearing if you put a batteries or something like this, like a positive and a positive go together, it will leak the battery acid. And if you put a negative and negative together and you put it in, it will also leak acid.
Oh, that's interesting.
They tell you to do like one side is one way, and so they tell you to go like this. Because if you go like this, so that both sides are positive, that leaks battery acid.
I didn't actually know that. That's really interesting. Luke, go ahead.
I don't have any magnets.
Do you know if you have any in the house at all? Let's think. Is there any household items that might have magnets inside of them? Does your mom have any like cosmetic cases, like makeup cases that have magnets, or do you have any bags that have a magnetic clasp on it?
I don't think so.
Okay. Did you already ask your mom, Luke, if she can find any magnets in the house?
Yeah, I already asked her. She couldn't find any.
Okay. So you're going to have to just watch then today and watch what everybody else does. And then maybe after class you could play.
Okay.
All right, go ahead, Bennett. I'm gonna unmute you so I can hear you, Bennett. What is that?
It's a little octopus.
Ah, oh, refrigerator magnets. That's another idea. Yeah. I don't know if that's probably not a refrigerator magnet, but it looks like maybe an octopus.
Oh, it is. You can stick it on your fridge and go. And stick it on.
Nice.
It has a little octopus on it.
Fun. Okay. Is everybody doing the different experiments it said on your worksheet? Oh, go ahead, Vivian.
I just want to say something that I found out really weird. I got my mom's deodorant, and there's actually like this weird pull. Like it doesn't stick very much, but there's like a little bit of a pull. Like,
Really?
towards it. It's weird. I'm like, whoa.
Oh, I have to try that. I'm gonna go get my deodorant. I want to see. You can trick people.
Mom, can I play on your phone?
I can't tell. I feel like I can. But it's so slight, I don't know if it's in my head. I feel it too. Do you feel it too? Let me get the stronger magnet. Okay, here's a more powerful. I don't know if it's- Can't tell. I'm getting a headache, Mom. Sorry. Keep experimenting. do you need, Jess?
Just looking at schedule.
Okay. Oh, I wasn't muted for that. Sorry. We're listening to all of my chatter. All right. So I think we're going to come back and talk about what we found. So if you can hear me, come back. Hey, Ryan, can you toss me a few magnets? Yeah. Oh, and throw me my name tag right there.
It's really strong.
Yeah. Thanks. Thank you. Okay. So did you guys have fun playing with some different magnets? I had a couple of different kinds. I actually didn't have the donut ones. I have little circles, and I also have this name tag. It's my 4-H name tag, and it's a really strong magnet. You can see how hard it is to get it apart, and when I come close, how it clicks it. So what kind of things did you guys find out? Vivian, go ahead.
Magnets, some of them, they aren't strong as others. But I already knew that. But like the magnets, they go through like the bottom of shoes.
Yeah, well, it was funny because we pushed them around.
They were really
We went like
fast.
this. We put them like this, but
And
one
then
of
it
them,
just pushed.
and it moved the top thing around. This is a pretty thick shoe, and it moved the magnet on top.
So hold your magnet up to the screen. You must have a pretty strong magnet. Yep, looks like a nice strong magnet. All right, who else found out some things? I think I saw Bennett's hand up a second ago. Bennett?
I found fridge magnets, and there's a little paper thing on my mom's fridge. It's a little paper thing you can write notes on. It actually sticks to the fridge because it has a magnet glued to the back of it. I'll go get it.
Awesome. While we're waiting for Bennett, who else wants to share something they found?
Okay, so
There's Bennett. Go ahead.
right here,
Uh-huh.
there's a magnet attached, and you can just write stuff down on the fridge.
Yep. So
My sister has this also.
magnets have all sorts of great uses, don't they?
Yeah.
Okay, what else? What else did you guys figure out as you were playing with your magnets? Anything? Miley, go ahead.
It sticks to a computer.
It sticks to a computer? Oh,
Yeah, my dad has this computer that's like kind of metal-ish, and I stuck a magnet to it, and it kind of stuck. Not that well though.
mine doesn't stick to my computer, so our computers must be made out of something different. Okay, what else? So Miley was talking about different materials. Luke, what did you find out? What? Oh, you're stuck. Weird.
Stick your magnet to the black part of your computer, and then it works.
Oh, it's interesting. So we have iMacs, and Riley is on an older iMac, and hers sticks. And I have a brand new one, and it doesn't stick on the black part. Mine falls. Oh no, I dropped it. Okay, Joseph, go ahead.
Which
Oh,
Joseph?
sorry. Joseph Marshmallow, and then Joseph Wayman.
Okay, so if you have like a bunch of paper clips on the floor and you need to clean them up fast, if you get a magnet, watch how fast I can get them. Pretty
Nice.
fast.
That's fun. That reminds me of, have you guys ever seen they're kind of like a toy or a desk object where it's a magnet and a bunch of small metal pieces and you can actually sculpt them and make them look different? Okay, now Joseph Wayman, go ahead.
My little brother, he put a magnet on the computer screen and it made this icky spot appear on it.
Oh, don't
Ruined
do
the
that.
pixels and stuff.
Yeah, we don't want to break our computers. Let's not put it on there. I didn't think about that. That would be bad.
And since there's iron in breakfast cereal, I tried that, but mine didn't have enough iron in it.
That's hilarious. I did not think about iron fortified food, if it would be magnetic or not. That's a really good experiment. Good job, Joseph. All right, Bennett. Oh, and then Kendall and Dee after Bennett.
Well, I remember you talking about some sort of little ball toy or whatever. I know how to make a shark tooth out of those. Like form a little shark tooth.
Oh, out of those magnetic toys?
Mhm.
Fun. Okay, Kendall.
If you actually stick magnets on computers, it takes away memory and other things.
Yeah,
so it's not good for the computer.
Let's not do that. Mrs. Randy never said put a magnet to your computer. I never said that. That would be bad. All right. Anybody else find out things? I see Landon. Landon, what are you doing? Tell us about that. Oh, you can't tell us about it because your mic, something's wrong. Type it. Can you type it in the chat box? And we could read it. We'll have to figure out how to fix your audio. Okay, so anything else? Did anybody experiment with holding different sides of your magnets together? So sometimes when you put them together, they stick, right? And then sometimes though, if we do what to them? If we flip it and you push it and you can feel it. Do you guys give me a thumbs up if you feel that force? Now, isn't that interesting that all the forces that we've been talking about so far, you can actually see things touching each other. Like, you know, if you push on your hands, that's a force that you can see that it's touching. But with magnets, it's unique because it's not touching. Bennett, go ahead.
My computer sometimes goes a little fuzzy, and it went kind of like a little fuzzy when you put them together. But when they went like this and didn't go together, I actually saw the two waves, like two magnetic waves, pushing against each other.
Wow. Kendall, go ahead.
My speaker's messed up. Did you say something?
Yeah, I was calling on you because your hand was up. Did you want to share something? Oh, it looks like you're frozen again.
They said they were having troubles with their computer.
Yeah, I think that Kendall's is freezing up. While we're waiting for Kendall to come back, Joseph, go ahead.
One time I had a pretty strong magnet and it was really small, and when I like rolled it across the wooden floor, then like it felt the nails under it and like swiveled toward them.
Oh, how interesting. That would be fun to watch. Okay, so we're going to jump in now and watch a few experiments that he does because he has some materials that it's harder for us to gather.
I'm hoping that you had fun playing with those.
Uh-oh.
I'm hoping that you had fun playing with those magnets. I'm playing with one right now here. They're so fun to play with. I can tell you, I'm an adult, and this does not get old to me. Magnets are so weird. What is it that's so unusual about them? Well, I think the biggest thing is that it's because they can pull on things. They're a force, but without touching on anything. That's what's weird. In fact, A magnet's force, as you saw, can go right through a solid object like my hand here. Now think about that. Normally, in almost every other example in your life, if there's a pushing or pulling on something, it's because one object is touching the other object. They're in contact with one another. But magnets, they're weird. They don't need to touch something to pull on it. This is the property, this is the characteristic of magnets, which is their most famous. Magnets can pull on certain things without touching them directly. And it's actually this fact about magnets which led to their discovery in the first place. Have you ever thought about that? Where do magnets come from? How did we find out about them? The ones you have were made in a factory, but the very first magnets were actually found in nature. Nobody knows exactly when the first magnets were discovered, but let me tell you a good story about them, passed on to us from the ancient Greeks, who lived here in Europe about 2,000 years ago. Now, in order to make sense of this story, you have to know that the ancient Greeks, well, they wore sandals a lot, and those sandals used nails to keep the top part of the shoe attached to the bottom. You can see some of those nails right here. The story goes that an ancient Greek farmer went out into the hilly countryside to look for his sheep. But at one spot where there was this patch of bare rock, his shoes kept coming apart. He'd take 2 steps, and the nails would fall out of his shoes. So he'd fix them, and he'd take another step, and the nails would fall out again. This had him really scratching his head. He's thinking, what is going on here? He sat down beside the rocky area, and he tried to figure out what was happening. And that's when he noticed that the rocks themselves were pulling the nails out of his shoes. The name of this place was a region of ancient Greece called Magnesia. And the word used to describe something that came from Magnesia was magnetes. And so these strange nail-pulling rocks, this is a real picture of one. You can see it's pulling on some paper clips. These rocks came to be called magnetes rocks, or for short, magnets. That's the story of how the first magnets were discovered, and that's how they got their name. Now, this story brings up another really important characteristic of magnets, which is that they don't pull on just anything. They only pull on metal. And it's not all kinds of metal either. They only pull on one kind of metal that you're familiar with. There are lots of different kinds of metals. There's copper, there's gold, there's silver, but magnets only pull on this kind. It's called iron. And they pull on steel as well, but that's because steel is a metal that is mostly made of iron. So of all these common metals, only iron and steel are magnetic. Magnets are only able to pull on iron or steel objects. The nails in that shepherd's shoes from the story, they were made of iron. And paper clips, they're made of iron too, which is why we included them for your experiments. Now, through those experiments, hopefully you discovered some of the other secrets of magnets too. Like this, let me show you something. You know that this paperclip, it's not a magnet. It can be pulled on by a magnet, but it's not a magnet itself. But hopefully you saw when it touches a magnet, now the paperclip acts like a magnet too. And so now the paperclip itself can pull on or attract other paperclips. You can just keep adding them like this. So that's another secret of magnets. When a piece of iron touches a magnet, the iron becomes a magnet itself. We have a word for this. We say that the iron has become magnetized. But here's something you might not have thought to experiment with. Does the iron stay that way once it touches a magnet? Like if we were to pull these magnets here away from the paper clips now, will the paper clips stay magnets? Will they stay magnetized?
Okay, let's try it. Who has their paper clips? Magnetize some paper clips and then pull the paper clip away and see, does it stay magnetized?
Oh, can I use your stronger magnet?
Mm-hmm.
With weaker ones, you can't even get it to me.
Here you go.
No, it doesn't.
Okay, I'm hearing no, it doesn't, and I'm hearing yes, it does. Give me a thumbs up if you think it does, and a
Yes, it does.
thumbs down if you think it does not. Does the magnetized paper clip stay magnetized? Yes or no? I see no, 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 no. Okay. I think we have something else that's going on. Oh, Bennett said, I just looked at the chat box. Bennett said if you put a magnet on a TV or a computer in just the right spot, it'll make it turn off. Probably something that we don't want to try, though. Because like Kendall said, we can damage the computer that way. Landon said he's making a paperclip fly. Kendall's internet was freaking out. We saw. Sorry about that. All right, so I'm hearing a lot of yes, a lot of no's, and not very many yeses.
It does. It really does.
Riley says yes. So it'll stay a magnet for quite some time, but if you drop it hard on the surface a few times, what happens then? So the answer is actually yes, it does. Look at Riley's paper clips. She took it off of the magnet and it still has magnetic properties. Now Riley, drop it really hard on the surface and then see if you can make it magnet again. So when you drop it really hard, it takes away the magnetism.
It's like you have to recharge it.
Now, Riley, what was happening? I gave Riley, first she started using one of these magnets and it didn't work. Then I gave her a different magnet and then it worked, right? So what's happening is that the first magnet she tried, it wasn't strong enough to magnetize the paper clips. So if you guys were experimenting and you couldn't get it to work, chances are your magnet wasn't strong enough to keep it magnetized. So you can turn a paper clip into a magnet, but it won't last. All right.
Another fact you hopefully discovered through your experiments is that a magnet's force is stronger up close. But as you take an iron object and you pull it farther away, you notice that the magnet's force is weaker when you're farther away. So you can kind of just feel this by holding the paperclip close to the magnet and then pulling it away. But a more dramatic way that I can show you this is by using iron filings. That's this stuff. It's iron that's been broken down to be very fine, like a powder. And then I've got a magnet under a clear plastic container here. So what I'm going to do is I'm going to sprinkle the iron powder over the top of the magnet. And this way, we can see where the magnet's force is strongest and weakest. You can actually tell where the magnet is invisibly pulling on the little bits of iron. Isn't that cool? Iron powder lets us do some pretty crazy things that you couldn't otherwise see in class. Like if you mix it with silly putty. You know this stuff? You ever played with silly putty? It's this stretchy, rubbery material. It's kind of like Play-Doh. Now, on its own, silly putty is not magnetic at all. But when iron powder is added to it, well, guess what? You've just made magnetic silly putty. Silly putty that can be pulled toward a magnet. So there's a magnet up here at the top of the screen. Check it out. Ooh, isn't that crazy? The silly putty is now magnetic because of the iron powder in it. Looks so weird. Or here's my personal favorite. This is iron powder mixed with oil. So if you do this, then you've got a magnetic liquid. Whoa, see this stuff? Really crazy and fun. You can pull on it. So those are some fun examples of things you can do with iron powder. Now, it's weird enough that magnets can pull on iron without touching it directly, but there's another great secret of magnets, which I hope you discovered through experimenting, and I've saved this one for last. And that's how magnets act around each other. In other words, what happens when you have two magnets and you bring them together? So hopefully during your experiments, you saw this for yourself. You tried stacking magnets on a pencil. You could stack them like this, and they pull each other. But now instead, if you take that top magnet off of there and you flip it over, what did you notice as you bring it down? Now the force is totally different. They're pushing on each other. You try to shove them together, you can really feel them pushing against each other. Whoa. So it's like they're hovering when they do this, almost as if like magic. See, magnets have two opposite sides depending on how you have them facing. They either pull each other, or if you flip it over, they push each other. Scientists call these two different sides of a magnet the magnet's poles, but we'll explore that another time. So this kind of hovering could make for some really cool inventions. I'll bet you could come up with some. Now, I'll show you one example to get you thinking, and that's this train in Japan. Instead of having wheels the way an ordinary train does, this train has powerful magnets, and the track itself is a powerful magnet. With the two magnets, the magnet of the train and the track, flipped so that the train hovers above the track. It doesn't hover very high. It might be kind of hard to tell from this photo. So let me show you the view from inside the train, where a passenger has set up some paper clips on the floor of the train. Now watch what happens as the train starts to move. Whoa, isn't that awesome? So hopefully all of this gets you thinking about some useful inventions that could be made using magnets.
Okay, what did you guys think about that? Riley, go ahead.
It looks cool.
Bennett, go ahead.
When you mix the oil with the magnetic dust or whatever, I typed in, "Holy cow, it's venom!"
So it was.
That's exactly what he does. He
Nice.
just that.
It was iron shavings. Yeah, I would love to play with that. Joseph, Marshmallow Joseph.
I really liked the silly putty one. That was really cool how it just kept engulfing the magnet.
Yeah, I wonder how hard it is to get it off of the magnet, though.
Just put a stronger magnet.
Oh, Riley says just take a stronger magnet and pull it away, but then it would be on your stronger magnet. Vivian.
I thought that if the train was magnetic, I think that would be actually really scary, because what if the magnetic force, what if it got really old or something? What if the magnetic force went wrong or something? The train would fall. You die.
You know what? That would be a fantastic narration to do for science, or for I Wonder, or just exploring questions in general. How exactly do they break a magnetic train? And have they ever had any accidents before? Like Vivian is saying, what if something happened with the magnets? What if they got to a part of the track where it wasn't magnetized anymore? Instantly, your friction, what would happen to the friction? Bennett, what would happen?
The thing I'm saying is, what if the magnetic force was so powerful that it went like this and then kind of tipped over like that or something?
Oh.
If it did, the friction, it would probably just slide across and go off like this if there was no magnet.
That would definitely be a worry. They would have to figure out a way to make sure that it doesn't flip off, right? And actually on that train, did you see, I noticed that the train kind of lipped around the bottom like this. I think maybe that's why, so that it doesn't come off the track. I think I saw another hand. Was there another hand up? Who's feeling really inspired to go on Amazon and find some iron shavings to play with? And some really heavy-duty magnets. I think that would be really fun. All right. So there's lots of different possibilities of things that you can make with magnets. They showed us the train. Is there anything else that you guys can think of that you could use magnets to do? Bennett, go ahead.
Hovercrafts.
Hovercrafts? Yeah, you'd always have to have a magnet underneath to be able to get that force. Makes me think of the slides. Remember the slide and fly? Is that what it was called? What if the slide and fly was magnetic and you went down instead of water, it was magnets? Might be dangerous. Josh, go ahead.
So, two things. It was called the slip and fly. So,
Slip and fly. Thank you. I knew I was wrong.
And I don't know if this is entirely true, but it looks like, because I like to play with fire. So I lit a match and stuck the head right up next to the magnet, like I'm doing with the camera.
Uh-huh.
And the flame was pulled toward the magnet.
Really?
Yes, really.
Ooh, that's interesting. You know, I don't know much about that, but I would love to experiment more with that. If any of you experiment with fire, make sure you have your parents' permission first. And you know what? I'm gonna look that up really quick. Let's see. Sometimes we can just do a quick Google and see what we can find. Let's type in magnets and fire. Candle fire flame bent by magnet.
Gotta love how the magnet interacts with the fire.
Oh, that's
See how
so
it bends the
interesting.
fire around its circular area. You can see right through it there.
Okay, so now I'm going to say, why does a flame bend with...
See how the magnetic fields bend it around? That's because the magnets are bumping the dark matter like the other video.
Well, so he just said that it's the forces of the magnet are actually pushing on the flame. Let's see what this one says. It says, can magnets control fire? So it says that the electric and magnetic fields will induce dipoles in a plasma just as they do a natural solid, but to an even greater degree. However, the net effect of dipole interactions, I imagine, would be significantly less in the path of a flame. So it's the forces of the magnet actually do push the flame. And I bet we could find more information about that. That's really interesting. I'm still curious exactly why that happens and how it happens with the flame. And so that would be a fantastic things to research after class as well. Josh, go ahead.
I also tried the same experiment with cast iron, and it did not have the same effect.
So cast iron, it didn't stick to cast iron? Or was it just less?
I kind of have to show you if you want to get it, if that's all right.
Yeah, go ahead. Okay, so that's his cast iron pan. There's the magnets.
So with cast iron, I put the top of the flame on it, but it doesn't move around, like it doesn't get pushed back like a magnet. It just how to say it? You kind of have to watch it. So with cast iron, doesn't do anything.
Ah, I see. So,
but then if you take a magnet,
I see what you're saying, Josh. So you're saying that the cast iron doesn't affect the flame.
Yep. And another really cool thing is if you hold the match, like, if you just hold it straight up and put the magnet above it,
Mhm.
the flame kind of goes away.
Wow, that's so interesting. So it's probably a good thing. It's probably a good thing that the flame doesn't move when it's on the cast iron, because we use that to cook, right? We want the flame. We want the flame to stay put. Bennett, go ahead.
So cast iron, it's, I think, supposed to be unmagnetic, because when you cook with it, you don't want the fire going from here all the way to here.
Yep, exactly.
Over it.
That would be bad.
There are actually some pans that do that, like they cook it, and it just goes boom, like a big fire comes up, and they say it cooks it a lot faster.
Nice. All right, so I at least I've been inspired to research all sorts of other things with magnets and flames and iron shavings. Have you guys been inspired to go and search? Because remember that science class doesn't have to end when we are out of class. If all you did for science was come to this class once a week, you would learn, but it would be just this much. If you guys now take what you've learned and you go start researching more, you can learn so much and discover so much. So I encourage you guys to, after class, jump into the drive, and you can look at the Dive Deeper section, and you can do those experiments, and then you can keep going and put what you do on your portfolio and tell us about it on Facebook, because I'd love to see. Vivian, go ahead.
I'm wondering if the deodorant, if there was any little pull in it. Like if it pulled it just even a little bit.
So while we were doing our experiments, I went and grabbed my deodorant, and when I first held it, I thought that I felt something too, and then I got my stronger magnet, and I didn't feel it so much.
I don't feel
So then I Googled it, and I said, is deodorant magnetic? And I couldn't find any information about it, so I'm thinking that it's not. But it's weird because when I first held it, I thought I felt some kind of a pull as well.
I think it was because of gravity, Mom. You were holding it like this, so you felt gravity pulling.
Riley thinks that I was feeling gravity pull. I don't know. Sometimes when we have an idea that we think something's going to happen, then we can subconsciously think that it's working. I honestly don't know. I think that would be fun to research more and see if you can find an answer to it. So the one last thing I wanted to talk about was some of you did not know about the book. And I have not talked about it in class yet because we haven't had any discussions, but it's on the book list for this class, and it's been on the schedule since the beginning of class. If you go to your schedule, you'll see Mesopotamia, Chapter 1, Chapter 2, Chapter 3, Chapter 4, Chapter 5, yeah. Eventually, we're going to have a discussion about this. And especially if you are, the neat thing about this is it's science in the ancient history. So especially if you're in the history classes or if you're studying ancient history right now, this is a really great book because it talks all about science in ancient history. Kind of like how today we learned that magnets were actually discovered in ancient Greece. So it is part of this class. I want to say it's optional. It is part of this class to read it, and we will have a discussion on it later. But if your parents don't want to purchase this book, have them email me about it, and we can talk, okay? And I could probably point you to the same direction of the information in different ways. But definitely have them email me. So, does everybody know what they're supposed to do after class? Raise your hand. Somebody tell me. What should we be doing after class? Kendall?
Looking at the class drive.
Yep. And why? Why should you look at the class drive?
So that we know what homework we need to do.
Yeah, there isn't really homework per se. If you go to the class drive, you're not going to see something that says homework. But you will see something that's called dive deeper. And what's dive deeper for? Vivian, go for it.
For things you do at home to dive deeper into the subject. Yeah, to get smarter in the subject.
There you go. To get smarter, to learn more, to fill your head with more knowledge. Joseph.
But if we didn't do the worksheet in class, we should do that too.
Fantastic. Yes. If you didn't have your worksheet printed off, then you should print it off after class and answer the questions and fill it out. I think that would be fantastic. Do you have another? Is that still, Joseph? Do you have? Oh, no, it was your string connected to your magnet. Thought you were raising your hand again. So, Joseph W.
I just wanted to say something about magnets again. If you wrap the magnet in plastic wrap, your iron stuff won't stick to it, and you can just clean it right up quick. Take the plastic wrap off.
Interesting. Yeah. Oh, that's a fantastic idea. So that if you wrap that magnet, he's saying, in plastic wrap, and then you had the magnetic silly putty go all over it, you could just pull the plastic wrap and it would clean it off. Fantastic idea. Good job. All right. So experiment with magnets more. Go play more with magnets. If you have your parents' permission, everybody raise your hand that you're listening to me say parents' permission. It might be fun to play with magnets and fire with their permission. And yeah, let us know next week what you found out, if you found out anything more. I'll stick around for a minute if you have any questions. Otherwise, see you later. I had fun in class today. Thanks for coming.